Let's define space complexity of a function. Now space complexity of a function can be expressed as, we can say, how many variables the function needs to perform its task. So those variables make up the space complexity of the function. And when we do that, we ignore the input parameters the function is getting. We don't need to account that in our space complexity. Usually when we represent space complexity of a function, we always represent it as an expression, same way as we do time complexity. So this will be either an expression, or we will say it is constant space requirement, which is expressed as big O of 1. Let's take two examples and it will become very clear to us what space complexity is. Imagine if we are given an array of size n, and this n can be anything. It can be 1, 10, 1000, 20,000. And it is given to us that first half of the array is sorted and second half of the array is also sorted. So you can see an example here. 1, 3, 5, 7, 9 is the first half, 2, 4, 6, 8, 10 is the second half. Both of the halves are sorted, and the goal is we need to merge both these halves into a single array so that they become completely sorted. Now in order to accomplish this task, we can take one new array. We can declare a totally new array of size n, and we can start copying the elements from first array, given array, to the new array so that they are sorted completely. When we accomplish this task, when we do this task, we say we have taken a totally new array of size n. So these n variables we are using to accomplish our goal. Now apart from these n variables, we will also use a variable which will run in the loop over the first array, because when we merge two halves of the array, we may require one or two variables to merge these two elements. So ultimately we can say we will require n plus 2 variables to accomplish this task. Since we are using n plus 2 variables, we can say space complexity of our function is n plus 2, because those many extra variables we required. Second example, if we take a look at, if somebody says you are given an array of size n and we need to return sum of all its elements, so we need to add all the elements of the array. So we can manage to do this by using just two extra variables, one for loop and one sum variable, using which we can add all the elements and store in the sum. So this we will say, since we are using only two variables for any given array size of n can be 100, 1000, 20,000, we can say however bigger the array is, we are using just two variables to accomplish our goal. So since 2 is fixed, we can say our function has a constant space complexity, right? So keep this one thing in mind, that taking few fixed number of variables is always considered to be a big O of 1 space requirement, or we can also say it's a constant space requirement.